Hello everyone! This is the second part in solving area of the oblique triangles given here. These triangles, rather, were already discussed as part of practice exercise B on the same lesson, the law of cosines. Please again don't be confused as to why this practice exercise or the computation of area is placed for the same lesson because the same triangles here were used under practice exercise B in solving for the measurements of the remaining sides using the law of cosines. Observably, triangles in numbers 1, 2, and 3 has this specific relationship. They're all under SSS situation where all the sides are given and none of the angles are given here. We do have a formula that could solve the area of the given oblique triangle even if there are no angles given. The formula is actually what we also know as the Heron's formula. Heron's. This is actually coined for with respect to Heron of Alexandria as one of the uh, ancient individuals who started using computations of areas, not just for triangles, but for other polygons as well. The formula is stated in this manner. The area is computed as the square root of S times S minus A times S minus B times S minus C, where A, B, C are what we know as the side measurements, or it could also be represented by others lowercase letters, specifically when we reach triangle number 2 and triangle number 3, where we use other variables aside from A, B, and C. But what is this S here? Not be confused with this S as the S I'm going to present here later. So just to make difference between the two, let me just use another letter here. Let us just use this Q so that we will not be confusing ourselves with what is this S here and the S supposedly to be given by the side directly opposite the angle S. So I'm changing it to angle Q right now so that there would be no more S's in these three triangles here. So again, A, B, and C are given as the side measurements, while S is computed as the perimeter of the triangle divided by 2. This is constant, okay? This is constant. It's not divided by 3, it's not averaging, but it's just simply perimeter divided by 2. As we all know, perimeter is the sum of all sides, which could also be represented as A plus B plus C all over 2 for the formula for the S here. Now notice why is it that we have a root here? Because if we're going to do this process here, this is actually with a unit and also have a unit here. So we have four different factors to be multiplied to each other. And hence, if we reach number 3 or even numbers 1 and 2, our unit would be raised into the power of 4. That's why we have the root here to make use of the root of the power of 4, which is actually 2 or squared pattern to what is really the area. If you want to know the derivation of the Heron's formula, I could also show it to you using a given derivation if you would like to. But in this given practice exercise, we are just asked about the area of the given oblique triangles using this formula. And this formula again is only possible for SSS situations. Let's proceed to number 1. Number 1 has this triangle ABC with the measurements of the sides. Of course, you could always use this as your A, as directly opposite angle A. This is your B, and of course, this is your C. So for us to get the area, let's start solving first the value of S. S is actually the perimeter over 2. In short, let's add all of the sides. You have here 9 plus 11 plus 6 all over 2. And that's actually 26, if I'm correct, all over 2. So your S is 13. This is the value you will use for this formula here. So let us now solve the area. Let's use a different color to represent the area. So area is the root, square root specifically, of the product of S, 13, times 13 minus the value of A, which is 9, times 13 minus the value of B, which is 11, times 13 minus the value of C, which is 6. So area here further is equal to 13 times, you have here 4, times, you have 2, times 7. Let me check it. 13 minus 9 is 4. That's 2 and that's 7. And your area is computed as the square root of the product. Of course, you're allowed to use calculators. If you would like to, you could always use the calculator on your laptop or cell phones, or even your calculator really that is with you. Or you could always use this calculator here as shared to you before. To do this, let's just try to multiply first everything, okay? So you have 13 times 4, rather, everything on the radicand. Okay? 13 times 4 times 2 times 7, that's 728. And take the root of 728, you will get a result equal to 26.98. So this is the area of the given triangle. But then again, we are going to round it off or approximate it into two decimal places by rounding off that said place. So that's 26.98 approximately. So you will have here approximately, the area is approximately 26.98. Since it doesn't have any unit, so we cannot write the unit here, but since this is an area, let's just declare this as square units. So this is the area for the first triangle in number 1. Okay, so again, we use the Heron's formula, but in order for us to do that, we were able to solve for the S first, which is the perimeter over 2, and substitute it in our Heron's formula to get the area. Proceeding to number 2, we have a different given here. As I mentioned, just to have no confusion with what really S is, I changed this to Q, so that there would be no more problem. Hence, this is actually Q here, this is R, and this is T. Nevertheless, what we're going to do here is to solve first the value of S, which is computed as the perimeter divided by 2. So that's Q, you have 6 plus 4 plus 5. Definitely, it's commutative, so you could always decide on your own which addend or which side you would like to write first. That's automatically what value. This is given to us 7.5, if I'm correct. Okay, 7.5 or 15 halves. Now, since 15 halves is a terminating rational number, which is 7.5, it would be also good if that's what we are going to substitute here in our formula later. Because it would be confusing for the rest if you will have plenty of fractions or rational expressions here. Of course, you could always use that, but if you could make it easier, then why not? So let's try to use that value in getting the area. But please do not be confused with the decimal as the unit of multiplication, or the process rather, or the operation of multiplication, since we have been using parentheses for that. So we have here 7.5 times 7.5 minus, it's up to you which side you would like to write first, because multiplication is also commutative. So you could have 7.5 minus 6 times 7.5 minus 4. And lastly, you have here 7.5 minus 5. So you will have here the product of 7.5 times 7.5 minus 6 is 1.5. You will have here 3.5, and you will have here 2.5. Okay, let me check. 2.5, 3.5, correct. 1.5, yes, that's correct. And then 7.5 here. So you could approximate this again for your area. Let's use the same calculator. So we'll have here the product first of the radicands so that we will not have any problem with possible confusion in the calculator. So you will have to click AC to remove all. So you have 7.5 times 1.5 times 3.5 times 2.5. That's equal to 98.4375. Again, 98.4375. Earlier, the product of this is actually a whole number, so it's easier for us to just use mental math. But since we have this, of course, the calculator could always help us um, process our operation. And then take the root of it. So 9498 rather. So let me just write this here so I will not be able to forget because I might forget the value. 98.4375. 98.4375. Let me check. All right. So then, if I'm going to click the square root of that, square root of 98.4375 equals, you will get an approximated value to 9.92 square units. This is the answer for number 2. Sorry, that's units. Okay, so this is how we do it here using the Heron's formula. And finally, for number 3, you also have sides. You may or may not construct this one, but if you would like to, it's okay. But definitely, we don't need construction to determine the area since do have the formula here. So let's use this. Let's get first the value of the S. And the S is the perimeter over 2. So that's actually 21 plus 16 plus 34. Okay, divided by 2. The value for S is given to us. Okay, we have 71, if I'm correct. 71 divided by 2, that's actually 35.5. Let's try to check. Okay, so definitely it's always good. Did you have a backup here? It's not a weakness if you would like to check it. No worry about that. You could always do that. But of course, we could always encourage you to apply mental math if you would like to. This is a value for S, so let us try to use that as we move further here for the area, which is the root of the product of 35.5 times 35.5 minus, this might be too short, so let me increase this for a while. I have plenty of space at the bottom, but in a horizontal perspective, it might not fit. So 35.5 minus 21. You have 35.5 minus 16. Sorry, 16. You have 35.5 minus 34. Right? So you have here the root of 35.5. Then you have here times 14.5. We are going to check it later if we are not too sure about it. You have 19.5 and you have here 1.5. Again, if you're not too sure about it, you can always check your processes. 35.5 minus 14.5. That's sorry, minus 21. But that's also another way of checking it. Let me go back here. 21, so 14.5. Change 21 to 16. Sorry, back. 16, so 19.5, that's correct. And 34, definitely that's correct. So you're going to multiply this, all of this, and take the root. So let's do it this way. 35.5 times 14.5 plus, times rather, 19.5 times 1.5. Let me check. 35.5, 14.5, 19.5, okay? Equal to this value here. We can copy this if you would like to. Okay. But of course, we could do it like this. This is now equal to the square root of the value 15056, 15056.4375. Again, do not round off yet because we are going to do rounding off on our final answer. 15056.4375. And now the area is approximately the square root of it. So you have here the square root. Sorry, I haven't clicked equality yet. So equals. And then you have the square root of the answer. 15056.4375. You have here 122.70, approximately 1.22, sorry, 122 rather, not 0.22, 120, sorry, 122.70. Notice that in our process, we have not included the or the unit because it may confuse some of us. So let's return the proper unit. It's feet here. So you have to place here square foot or feet squared. This is now the area for the third triangle. We can solve the area of an oblique triangle using the Heron's formula under SSS situations. You could use this as part of your review. Again, I could show you the proof of this. I'm going to provide you another video as soon as possible. Thank you very much for watching. Please make use of this as part of your preparation. Goodbye, everyone.